This is lesson 8.5a in trigonometry, polar equations, and graphs. This is going to be rather long as far as the lecture is concerned, but we have one more lesson in this chapter and then three more in the next, and the three more in the next will be a lot easier compared to what we've been doing. This is going to be not necessarily a challenging lecture, but it's just going to be a long one. Alright, so let's get started here. We're going to make a change here, and we're going to look at the polar coordinate system. So, at this point in your life, you've been using the rectangular system. Given an x and a y, you can graph a point. This over here is a polar graph, and it's a little bit different in that. Let's make it a little bit bigger here so you can see what you've got. Instead of getting a go over this many x and go up y, which is real hard not to get confused with, but instead it is, here's my x-axis basically, and here's my y-axis at 90 degrees. You kind of superimpose this polar coordinate system on your x-y axis, and you first of all take your angle. So you go up 30, and then whatever the length of this is, so let's say it's right there, okay, that is your R. So you're looking for that, or your radius, your hypotenuse, whatever. One of the things to keep in mind is this point, you did not go over X and up anything. You started at 0, you went 30 degrees, you took the length of R, started there and said it's 4 inches, so you went from here 4 inches to here. You never use the x-axis as 1, 2, 3, 4, 5, 6, 7, 8. Don't even go that way, and people have a tendency to do that. That's why I say, first of all, you go your angle up and then the length. So what that looks like is R theta is how it's graphed. Or let's say that R is 3 and theta is 30 degrees. That's the way you label it. Now in the rectangular coordinate system, you have an x and a y. You go over x, up y. In this, you do the opposite. You go up 30 and the line is 3 long. Let's say that's 3, and that's where your point is. So up 30 and then 3 from your origin to there. Okay, so this is called the polar axis. The other one that we had up here is the rectangular axis, which is what you're used to doing. So let's go ahead and shrink that down, move it over, and there is the rectangular axis that you're used to doing. Let's get rid of that because we aren't going to be using that in this section. Alright, so let's bring this out and look at a couple things here. First thing we're going to look at is that the length of our R, so if we have it this long, the length of that is always going to be positive. But sometimes we may go in the opposite direction. So it could be that maybe instead of going that way, we go this way. So our R is still the same length, but we went in the opposite direction. So we're going to call it a negative R. R is still the length, and the length is always positive. Negative, all it means is that we went in an opposite direction. So this point right here would be labeled negative R and then theta, whatever theta is from here all the way around to here. Okay? If I went from here, the 0, this way, it would be negative R negative theta. So it would be the length of R in a different direction, and our angle we went in a different direction. But we'll get into some of that in a little bit. Alright, so let's get rid of some of this and move our graph out of the way here. And we're going to look at this. Now, you're used to rectangular coordinates, x and y. Now, if we want to look at how they're related, remember we said polar coordinates are listed as the radius, the length of the radius, and the angle, theta. Alright, so cosine of theta equals adjacent over hypotenuse, or x over r. If we are looking for x, x then equals r cosine theta. So if we were trying to translate from polar to rectangular, we would just know that x equals the length of the radius times the cosine of whatever angle that is. We also know that y, or sine of theta, equals opposite over the radius. So if we wanted to find out what y is, it would be y equals r sine of theta. So that would give me my x and my y values. Another important part of this is going to be r squared equals x squared plus y squared, or r equals the square root of x squared plus y squared. This here, they put it on there. I don't even think we're going to use it in this lesson. I think we'll be fine without it. Okay, so remember that graph on page 3, or that blue on page 359, because we will be referring back to it a lot. Alright, let's keep going. I'm going to start a new video since I'm already over 7 minutes.